In this video, what I want to do is talk about the following issue that we could have with subspaces. So what I'm going to do is I'm going to consider the following subset of R2. Remember, subset just means that it's living inside R2. So these are vectors in R2, in other words. And what we want to know is E a subspace of R2? And so that's the question. Well, right off the bat, the answer is no. You can check that it fails the subspace test. And you can really just take, say, 1 plus x1 plus 1 plus x2. And what you get is not 1 plus anything, it's 2 plus something. So that means that this is not in E. So that means that the subset is not closed under addition. It also fails to scale. So if you were to put, say, k times 1 over x, that would be k over kx. And for any constant other than 1 itself, this is not going to be an E. Okay, so it definitely fails the subspace test. So this fails the subspace test, which means that E is not a subspace. And that's fine. This is actually something that I think we already knew. We might have even gone over this explicit example before. But what I want to emphasize is that there's a way that you can just look at this and just say, nope, definitely not a subspace. And the way that we know that is that, remember what a subspace is. So the idea is that you have all the possible vectors of R2 in a pile, okay? And then what we're going to do is we're going to take a collection of those vectors, and that collection is called a subset. Maybe that collection so maybe it's the vector E that we had before. I probably shouldn't use the word E. Let's just let that be S. And so the idea is that maybe S is everything in R2. Maybe it's the collection R2 itself. Maybe it's got nothing in it but the zero vector. Maybe it's some other set like the set E that we were working with above. One way to quickly tell that a set is not a subspace, so this is only a useful trick to show that something's not a subspace, but remember a subspace is a subset. So I started to say this, but it's a subset that's also a vector space. So that means that it has a zero vector, it's got all the different properties, but having the zero vector is the important one. Notice that it doesn't matter what x is, this will never be the zero vector, right? So that vector 1x is never going to be the zero vector. That means that this is not a subspace because it doesn't have the zero vector. End of story. So a quicker way to do this is that, again, E is not a subspace. And the reason is that the zero vector in R2 is not an E. And that's enough just right away to say that it's not a subspace. That's a simple trick that we'll use in upcoming topics.